back to our Think Energy Hub and our Ask the Expert series. Today, I'm joined by Calin Tasnadi from the Hevac Group, and we are going to be delving into heat pumps. So before we jump into it, just to give you a little bit of background to Calin's experience and why he is our chosen expert for this conversation. So Calin moved to Ireland nearly 20 years ago and has worked in the Irish heating and renewable sector for more than a decade. He's a graduate of Building Services Engineering from the Technical University of Cluj-Napoca in Romania. And he's currently the Product and Compliance Manager for the Hevac Group. He's also part of the NSAI Technical Committee Group, delivering a standard recommendation for heat pumps, and is involved in the retrofit task force led by the Department of the Environment, Climate and Communications, looking at retrofitting 400,000 heat pumps into Irish homes by 2030, which is no mean feat, and we'll be delving into that a little bit further later on. Not only that, but he is playing a very important role in heat pump adoption here in Ireland. For example, he was involved in the development of the Heat Pumps Code of Practice Installation Guidelines document. He's also worked closely with SEAI, Dundalk IT, Cork IT, and METAC in developing a heat pump training course for the Irish market. So I think it's safe to say that Calin is absolutely committed to promoting renewables technology here in Ireland and elsewhere, I'm sure. And as he has said himself, creating a cleaner and safer environment for the future. Calin, personally speaking, I feel pretty confident having you lead the charge in heat pump adoption here in Ireland. Thank you so much for joining us, and you are very welcome to the Think Energy Hub.
Thank you very much, and thank you for a very kind introduction. I'm really excited, and as I said earlier, I love talking about heat pumps, and they're a part of our lives. So let's get going.
Brilliant, great stuff. So I think the best place to start is probably, what is a heat pump? How does it work? What is the purpose of a heat pump? Tell us.
Okay, brilliant. So a heat pump really, it's a device that transfers energy by means of electricity, right? In very layman terms, that's what we do. And when we take heat from inside and we transfer that outside, we do cooling. And then when we take heat from outside and we put it inside, we do heating. And I know probably everybody knows about this, but we all have a heat pump in our homes, and it's the fridge. And the fridge takes the calories, the heat out of the food that we put in it when we bring the shopping home. And then you will find a lot of the times you have, for example, cobwebs at the back of the fridge, or you feel warmth either on the sides or on the back where we have a radiator. Basically, that's just a way by the means of a refrigerant to dissipate that heat. So we do cooling in that instance, and the reverse of that is heating. So all heat pumps by that means can do heating or cooling.
Very good. I think that's a really good one to mention, that we actually do have a type of heat pump in our homes already, our fridge.
Absolutely, absolutely. It is there. You can then categorize them in two main, let's say, categories. We have air source heat pumps by their name, they're extracting that energy from the air outside, and not only, but outside mainly. And then we have ground source heat pumps, which will extract the energy from soil. Yeah. So ground source heat pumps have been, let's say, very popular in Scandinavian countries because you can have a constant temperature at very, let's say, big depths of 100, 150 meters, right? Mm-hmm. Or you can also have them in what is known with a horizontal collector, having them installed in your back garden, for example, to extract the energy from there. But the most popular ones over the last, let's say, decade have become the air source heat pumps. And these two also, they're broken into two big categories: air-to-air heat pumps, or they're the air conditioning units as we know them. Yeah, they can do heating or cooling.
Yeah.
And the most popular one is the air-to-water heat pumps.
Very good. And Calin, what are the main benefits of having a heat pump in your home?
Firstly, is comfort. So one of the main things that I always say is the comfort of you have also just one utility bill. So it's but comfort is the main thing. Heat pumps in particular work very efficiently when we deliver low temperatures. So we try to design heat pumps working at 35, 40 degrees, which will, let's say, feel just lukewarm to our hand, but it will work fantastic with an on-the-floor heating system, which requires low temperatures. So you will find most of the new builds, in particular for one-off dwellings that somebody will build a house for themselves. In 95% of the cases, they'll have on-the-floor heating working with a heat pump. Also, they deliver your full demand for hot water. So it will look really, a heat pump, I always say, it looks after your comfort.
Very
So
good.
it
I like that.
delivers heating and hot water.
Okay, brilliant. And if someone is interested in investing in a heat pump, could you kind of take us through the whole process? So, like, what the steps would be, literally from initial interest all the way to installation. So, for example, things that I'd really like to know would be, firstly, what does it mean for my house to be heat pump ready? Do you have to have
Yes,
a
yeah.
certain BUR to be suitable for a heat pump, that kind of thing?
Okay, there are two things I would say we should break this into as well. We have a new dwelling market and you have a retrofit market. So
Okay.
new dwelling is pretty straightforward, is governed by the technical guidance document. The newest one is TGD 2019, and part of that of it that looks at the energy end of things is called Part L. And on the Part L, we have to meet certain energy performance and carbon performance coefficients. In the last, let's say, 3-4 years, we found, for example, that you can easily meet these KPIs, they call them, by using a heat pump without any other renewable sources. So that is typical. You will have a heat pump with on-the-floor heating or low temperature radiators, and it works very well if we introduce also some sort of a mechanical ventilation, ideally with heat recovery. But that's let's say very straightforward for a new dwelling.
Mhm.
The challenge comes to a retrofit, and I would make a comparison with a car, for example. If you have an old car and you just decide to change the engine, it will not necessarily make that car go faster or better. So you have to look at everything else, tires and so on and so on. So if we move that comparison and we look in depth at a house, we need to ensure that for a house to be heat pump ready, right? We have to achieve certain levels of insulation in the walls, in the roof, in the glazing that we have in the house. So typically, by looking at those U values, we are looking at what is the heat load for that house. So in a retrofit scenario, in most cases, we should have a heat loss calculation done to ensure that we are, let's say, installing the most appropriate heat pump.
So, just to get this straight in my head, so we have to ensure that our house is kind of covered and insulated before we go and invest in a heat pump. We need to make sure that we have the wall insulation, the attic insulation, that kind of thing.
Exactly, exactly. So under the Better Energy Home grants that SCAI is delivering there for the last number of years, very successfully to a certain extent, let's say, uh, we look at let's say there is a heat pump grant. People know it as a heat pump grant. It runs under the Better Energy Home grants, and to see if you qualify for a heat pump grant, you have again to meet a few, let's call them KPIs, yeah, a few
Key performance indicators.
indicators, yeah. So one of them is the most important. Your house has to be built prior to 2011. So if your house is not built prior to 2011, you will not qualify for a heat pump grant.
Okay.
Uh, then you have to engage with a technical assessor. So there is a list on the SCAI website where we have a technical assessors throughout the country that will uh, basically come out and assess how suitable is your home to retrofit a heat pump. And by doing so, they will generate a BR assessment. And in that BR assessment, they will look exactly like what we said earlier, U values for the
Mm.
floor, for the walls, for the roofs. In certain instances,
Yeah.
your house can be heat pump ready. So you don't have to do any other improvements to your house, right? So you can, it's ready for you to install a heat pump system. This is very important. We don't
Yes.
just not install a heat pump. We put a full system in.
Okay. Okay. And just to as well remind anyone watching of what a U value is, because when I spoke to Eric Dennis before, he explained this to me for the first time. So we're saying the lower the U value, the better.
Yes, indeed. So every material has a thermal conductivity, and let's say that gives, let's call it insulation for argument's sake. It all relates to how well a material will transmit or not heat for argument's sake. So
Hmm.
less we transmit that heat, it means the less heat losses we're going to have. Therefore, let's say if we put only 100 mil, for argument's sake, of mineral wool or whatever insulation wall in our attic, we will not be that well insulated.
Hmm.
So typically they would advise to put about 300 mil in the attic, right?
Hmm.
So that, for example, Katie, is the easiest measure to do. So when you look at your house, how ready is it to retrofit a heat pump? There are very few simple things you can do. The simplest thing is to insulate your attic. About
Hmm.
30% of our heat, believe it or not, can be lost through the attic. Yeah, you will see, like the other day when we had a bit of snow, you could see the houses that are well insulated or not, depending how, if the snow is still on the house or it's melted. So basically, it just gives you
A
uh,
good
uh,
idea.
a good idea how well insulated a home is. Also, the walls and the floors have to be well insulated, but you can imagine, for example, to dig up floors in an existing dwelling. That is a very high cost.
Yes.
So for a retrofit project, a lot of the times you were looking to retrofit low temperature radiators rather than on the floor heating. So
Okay.
on the floor heating is built in, let's say, in your floor, and it is very hard to retrofit, or it's very expensive rather than
Hmm.
hard. So when we look then at a system, we typically would say you'll have a heat pump that will be connected to a heat sink. That heat sink is your heating system, and then
Okay.
you have typically either a 200 or 300 liter hot water storage tank, right? So once a technical assessor will look at your home and will say, for argument's sake, it's ready. This is a heat pump ready house, right?
Hmm.
uh, we have then to look to see, okay, how about your radiators? Because a lot of, or most houses built prior to 2011 that will have either oil or gas boiler will have the radiators sized for flow temperature of 75 to 80 degrees. For a heat pump to deliver that is very inefficient. Therefore, we have to look at as lower temperatures as possible. So we're looking at 35 to 55 max in heating,
Oh, wow.
which
Okay.
which this means though means that more than likely in a retrofit scenario, you will have to replace completely your existing heating system with new radiators, with new pipework. The cylinder has to be replaced as well. So under this heat pump grant, we have to supply 100% of the heating load and 80% of the hot water load.
Okay.
Uh, by 80%, we mean that, as mentioned earlier, if a heat pump delivers efficiently 55 degrees C, uh, for to store that tank up to maybe 60, we have to use an electrical immersion at least once a week, if not daily. So
Okay. In
therefore,
support of the system.
exactly, only on the hot water side. Yeah, so
Okay.
on the heating side, we will not necessarily have that electrical immersion kicking in.
Hmm.
We will have that only on the hot water side.
Okay, interesting. And how and where is it fitted in the home?
Okay, so I will focus on the air to water heat pumps because they are,
Okay.
let's say, 95% of the installations in the Irish market are air to water heat pumps. As mentioned earlier, we have to extract air from outside. So, and for that, we have what we call an outdoor unit.
Hmm.
That outdoor unit passes high volumes of air, and that transfers that energy from the air to a refrigerant, and that refrigerant, through a plate heat exchanger, passes that energy to water. Therefore, the name air to water heat pumps. Okay? Where we have the outdoor unit located, as I mentioned earlier, we need to be able to pass high volumes of air. So we have to ensure we have the space, let's say, beside our home. Ideally, we try to keep the outdoor unit as close as possible to the house to
Hmm.
minimize the heat losses through the pipework that will go in, right?
Makes
So I
sense.
ideally want to keep it as close as possible to the house. Uh, Inside then, you have what we call two main type of air to water heat pumps, split and monoblocks. Monoblock, as its name, it's all built in one, right?
Hmm.
It's like a boiler if you want, but it's not. But it transfers, so you have water connections outside, and that comes into the house, into your heating system and the hot water tank. As simple as that, right? You also have an option for a split system. With a split system, for example, the transference of energy from refrigerant to water happens in the house, where with a monoblock, that happens within the outdoor unit. So this is just to give an idea to people why what's a split, what's a monoblock. Monoblock has everything built inside that outdoor unit. In the split is only the refrigerant and compressor, and you transfer the heat in the house.
And is there a benefit to one or the other?
Yes, there is. It is not a massive benefit, but for example, with a monoblock solution, you have water in the outside unit, where with the other one you only have refrigerant, so you don't have to worry about freezing in case of a power cut. So
Yes.
that's a thing that we've been asked in the past. What happens if there is a power cut? We have introduced since what we call an antifreeze valve. You can install that very easily at early enough in the process on the return. And if the temperature, let's say, in that pipe drops below 4 degrees, that valve opens and drains the water. So it's very simple to install and very efficient. Still, some people prefer that. I said it's worth to be mentioned because uh, hopefully uh, people will get a bit more clarity about that. So these are the two main, split and monoblocks. Both will do more or less the same thing. Okay, so it's not a massive difference, let's say, between them.
Okay. Okay. So let's say my house is heat pump ready and you have completely convinced me that this is the best way forward. The next hurdle is cost.
Cost. Yeah, that
So
is
dun dun dun.
dun dun dun. Believe it or not, that is the biggest barrier at the moment on the
Okay.
heat pump in that the heat pump market would have to grow at the levels that we hope to grow by 2030. So, as mentioned earlier, under let's say new dwellings, we have to more or less put in a heat pump. Okay, so that is a cost that we have to incur anyway. Where when we retrofit is something that we would decide to do, and it can vary from 12,000 euros to 15,000 euros to 18,000 euros. So depends how big the house is. Depending on that, you will have, let's say, sized your heat pump to suit,
Hmm.
and then internally you will have, for argument's sake, the radiators to suit. Uh, if there's no other measures that you will do to your house, let's say on average 15,000 euros, it's a hefty sum. right? It's a big chunk
Yes.
of money to have there. Uh, but in saying that, if you have that money, this is I would always have a kind of a obviously I also try to sell heat pumps, and I would have encouraged my colleagues to always go for more of a softer sale rather than a hard sale, right?
Yeah.
And you try to say, okay, if you have that money, for example, uh, and if you keep it in the bank, you will gain more by replacing an old oil or gas boiler, yeah, percentage APR wise, rather than leaving that money in the bank. So this is the first thing, right? Uh, because then people will say, okay, but what is the return of my investment? When will I get all that back? Say, for example, if you put 15,000 euros in the bank, for argument's
Mm.
sake, and you apply, I don't know, 3%, yeah,
Mhm.
APR to it, at the end of the year, whatever that is very little. It's 350 quid, where with a heat pump, for example, you could save 1,000 euros, right, on your bills. So uh, just talking about that, it's a good moment to introduce what SCI they are issuing on a quarterly basis is their domestic fuel cost comparison. Okay, so I have here, I've printed something for our meeting today. The last one was done in January 2021. And here they give you costs per kilogram or ton or literage of different fuels on the first page. On the second page, they give you that same comparison and they look at cost per kilowatt hour delivered, right? So
Okay.
basically how much, for example, if I use kerosene oil, yeah, discounted oil, very cheap at the moment, by the way. So it makes a heat pump a very hard sell for a retrofit. But
Mm.
if you have a brand new boiler, a very efficient boiler that works in condensing mode, that will be costing 6 cents per kilowatt hour. Okay.
Mhm.
If we look at a gas boiler, this just I want to put it in perspective,
Yeah.
what means, how to compare it. So a natural gas boiler, similarly, a 90% efficient, we're looking at a delivered cost roughly at 6.8 cent, right? Uh, if we look at heat pumps, so we look at, there is the last table on the second page, it gives us different bands of electricity and how much electricity we would consume in a year. I would always look at the biggest one because
Mhm.
considering you have in a heat pump, you'll consume a lot of electricity. Yeah, that's on top of what your household will already consume.
Mhm.
And we see, for example, that if delivered day rate will cost you about 18 cents. Yeah, uh, if you apply to that an efficiency, and we're going to talk about efficiencies in a few minutes, of 4. Basically, what that means that you just divide that by 4. Yeah. So that means that per kilowatt hour, that will cost you 4.50, 4.5 cent. So that is about 30 odd percent better than oil and
Mhm.
about 50% better than gas.
Yeah. Yeah. That really does put it into perspective.
So this is what will now realistically we have to look at realistically so this is a what we call they and is also mentioned on the SEI table. It's a seasonal performance factor. So I just want to talk a bit about the efficiency of a heat pump. Yeah.
Mhm.
So as mentioned earlier, heat pumps can deliver very efficiently low temperatures. So ideally, you want to have it working at 30, 35 degrees all year long, right? And that's what the temperature is required for an on-the-floor heating system. And if you do that, you can actually achieve a very high seasonal performance factor, or SPF. You can go up to 4.5 or even 5. So for your heating requirements, for example, at an SPF of 5, it means that it will cost us 3.6 cent per kilowatt hour. So that's very good. Yeah.
That is very good. Yeah.
Uh, Now, there's a little caveat. When we deliver hot water, okay, that because we have to go high temperatures, the seasonal performance factor, it will drop at in between 2.5 and 3.
Mm-hmm.
So we have to average it out. So, for example, in a house full of teenagers that are having a lot of showers per day, that's going to be a big cost, right? So these are the things that we have to keep in mind.
Mm-hmm.
Okay? So when we deliver hot water, it's not as efficient as when we deliver heating with a heat pump.
Right. Okay. Okay.
Makes
So,
sense?
like your actual behavior in your home matters too.
Absolutely, Katie. Similarly, with the temperature, and I've seen uh, the previous thing on your tips that you have done about how we can do energy savings in our home. And one of the simplest thing to do that you mentioned was to bring down the thermostat
Mm-hmm.
by 1 or 2 degrees. Very important. What that translates is money in your pocket.
Which
And this is
no one can argue with.
absolutely is the simplest way to encourage someone. Okay, by doing that, just put a jumper on, really. So it's behavior,
Mm-hmm.
a change, right? So, uh, okay, if you want, you can have with a heat pump your house at 25 degrees all year long, but that will reflect in your bills.
Yeah, absolutely.
So these are a few things that I would recommend when somebody is looking at installing a heat pump to see whoever that heat pump manufacturer or supplier is, what would be should be the expected uh, SPF, so my seasonal performance factor
Mm-hmm.
in hot water mode, and what should be the one for heating, right?
Mm-hmm.
And I keep saying SPF because there are people there trying to sell you heat pump based on a COP, and that's a completely different thing. COP is a coefficient of performance
Okay.
and is mostly measured at 7-degree flow, 7 degree outside, and 35-degree flow. And that COP can be very high, can be 7, right? But that is only achieved in those conditions, 7 degree outside and 35-degree flow. So the true measure of an efficiency of a heat pump, it's a seasonal COP, or we can all call that seasonal performance factor.
Right. Okay. Yeah, that's good to keep in mind. And in terms of the payback of a heat pump, like obviously you've mentioned the efficiency, but how long can a kind of a household expect to take to pay back that investment?
Uh,
Difficult question.
Difficult question, yeah. How long is a piece of string? It is, so let's say, let's presume the house is heat pump ready, and let's
Yes.
presume the house uses oil, right? Uh, as you can see, oil is very cheap at the moment, yeah. So it's not a kind of level playing ground. Okay.
Yes.
So, for argument's sake, if your annual bill, oil bill, let's say, is 2,000 euros, right? Uh, let's say we have that. Let's just say we have that. So, uh, and the cost is to install everything is about, uh, to make it simpler, 13,500.
Mm-hmm.
You get a heat pump grant of 3,500, and you have been left, let's say, with your uh, cost of about 10,000 euros. So it will take 10 years to pay back
Okay.
in that instance, right? So uh, at the moment, that is one of the biggest challenges that we have, the
Yeah.
cost of retrofitting a heat pump.
Yeah, and I suppose as well, what you mentioned there in terms of the possibility of needing to, maybe take up the floors, that's not included.
Absolutely. Or for example, let's say this was for a house that is heat pump ready.
Yes.
Let's say is not heat pump ready. SCAI, with their, let's say, via their technical assessors, when they generate a technical assessment, they look at a thing called HLI, or heat loss indicator. Okay, and that heat loss indicator, we're aiming to be between 2 or 2.3. There is a little, there are a few things that you, if you have that recently you would have changed your windows to double or triple glazed windows, they will consider a higher HLI, let's say for argument's sake.
Yeah.
But they would say if your HLI, for example, is 2.9, for the argument's sake, they will say, okay, so that's not so bad. You can maybe just draft proof some windows, for argument's
Hmm.
sake. If I'm just saying, I'm giving examples, yeah. You can put 300 millimeters of mineral wool in the attic, okay, and that could potentially bring you down to 2.3.
Okay.
But if you are at 3.5 or 3.6, and maybe a 3.5 is reflected of a D3 rating or an E1,
Mm.
it requires a lot of uh, potential home improvements from an insulation point of view before you'll be ready with your home. Uh, Now they are applications. So as from a heat pump association point of view, right? Uh, a lot of our colleagues in the industry have argued that you could have a house that is even a 2.5, right, HLI that is suitable. Okay,
Hmm.
uh, we hope we'll be collecting data to prove that. I know, for example, there's been great work done by Tipperary Energy Agency via their Super Homes program, where
Yeah.
they have collected a lot of data. And even houses with 2.5, 2.6, maybe even slightly higher, they performed very well, right?
Okay.
So what to move maybe into the big challenges that are ahead of us to retrofit 400,000 heat pumps, we need to open that a little bit. So at the
Hmm.
moment, it's very restrictive and very costly.